And welcome back to COVID-19 edutainment videos. Today we're going to go into a subject that the Regents expect you to understand, which is how to make a weather station model. How to create a shorthand way of knowing the major weather variables for a location somewhere on Earth. The station models we will describe today are the type that are used in the United States using Fahrenheit, millibars, and inches for the amount of precipitation. So, a weather station model is described on page 13 of your reference table on the bottom, and you could spend some time looking at that. On the left, a completed model, not specified any location, and then a description of all the different variables that have to be placed around the model, including the present weather, which is filled out here. So that would be one of the variables right in this section, right in this section. Well, these are some of those present weathers that could be put there, including hurricane and tornado. And then down at the bottom here, you also have all of your air masses listed and all of your fronts. So you don't actually have to remember any of those. So we're going to now focus on just the station model and how you would put one together. The first variable is the temperature in Fahrenheit at the 10 or 11 o'clock section of our circle. The circle placed on a map at some specific location in the United States. Then, the amount of cloud cover in increments of 25. If it was 100%, we'd color in the full circle. It's 75 in this example, so 3/4 are colored in. Half, 50% cloud cover. A quarter of the sky covered with clouds, a quarter of the circle colored in. If the circle is white, we have no clouds in the sky. Then, the wind speed. The wind speed is designated by the feathers on the shaft of an arrow, the shaft of the arrow indicating the direction from which the wind is blowing. So in this case, the wind is blowing from the southwest. The wind speed is determined by these two feathers in this example. The large feather, or whole feather as they call it, is 10 knots always. The half a feather is 5 knots. So you simply add the two together. In this case, a 15-knot wind from the southwest. Here we would have a 10, 20, 5-knot wind from the northeast. Here we would have a 5-knot wind from the east. Here we would have a 10-knot wind from the southeast. And again, boom, boom, boom. Back to the station model, and one last time to say the shaft always pointing in the direction from which the wind is blowing. We do not care where the wind is going. We want to know where it's coming from, because the wind's origin will indicate the type of air headed in our direction. What kind of air mass might be coming our way. So wind direction in terms of origin is very important, not where it's going. That's someone else's problem, sorry to say. In this case, we can say that without being a nabob of negativity. Okay, visibility, half a mile. Very simple, put it at the 9 o'clock section. Present weather, what's it doing right now? And again, what are some of the things that we can include in that characterization? Drizzle or rain or smog or hail or thunderstorms, rain showers, snow, sleet, freezing rain, fog, haze, snow showers. Did I say snow here? I meant to say rain. Then, and you just add that based on what it's doing outside. Next, the barometric pressure. This is the most difficult part of the station model. In this case, the actual barometric pressure has been recorded at 1,019.6, but we don't write it like that. We write 196. Why? I don't know. But that's what happened in the history of station models. Somebody decided this was the better way to do it. So, how do we get to 196? Well, if you think about it, it's not that unclear. It's lurking right here in the 1,019.6. It's just simply the last 3 digits with a decimal point removed. Insert a decimal point. If we were going to decode 196, we'd put the decimal point back in. If we're going to figure out what it actually was in millibars, then we would have 19.6, and then simply add to it a 9 or a 10 and match your outcome, having added a 9 or a 10, with the millibar scale on page 13 of your reference table. So let's try it with a 9. 919.6, is that anywhere on this scale? No, that cannot be correct. 1019.6, 1019.6, is that there? Yes, yes, yes. So that must be the air pressure on our station model example, 1019.6. Test results, 919.6 is below, read reject, 1019.6 is within the range, accept. Yay! Then, if we were going to decode these, if we saw in a station model 002, what would it be? Well, it would have to be 1000.2 because 900.2 isn't on the scale. What about 993? Well, if I put a decimal here and I put a 10 in front of that, I'd have 1099.3, which is not on the scale. It must be 999.3. What about 280? Can it be 928.0? No! It has to be 1028. Boom. And finally, 000. Can it be 900? No! It has to be 1000. 100.0. 1000.0. Sorry, not enough zeros that first time. Okay, that's decoding. Then, oh my God, the next part, so confusing. What was the barometric pressure 3 hours ago? What was the barometric pressure 3 hours ago? That is what this plus or minus with a forward slash or a backslash can tell you. In this case, the current air pressure is 1019.6, indicated by 196 on the station model, and the barometric trend has been going up, which means 3 hours ago, it had to be lower. How much lower? Turns out 19 on a station model doesn't mean 19. It means 1.9. And so we have to subtract 1.9 from 1019.6 to find out what the air pressure had been 3 hours before. So we'll just look at that for a second. The trend, again, it's either a negative or a positive. In this case, a positive. It's either a forward slash going up or a backward slash going down. Higher, lower. 19 means 1.9. Forward slash rising, backslash falling. So what was it? Again, 1019.6 minus 1.9, which must equal 1017.7. You check the math yourself. How about this one? Here we have the barometric pressure going down. That means it was higher 3 hours ago. That means negative 2.8 has to be added, not as a negative, but just 2.8 has to be added, 2.8 millibars to 1000.7. We have to add 2.8 millibars. We have to raise the current air pressure, which would be 1000.7, couldn't be 900.7. And if we do that, 2.8 plus 1000.7 is 1003.5. It's so confusing. So that was our trend. Then, precipitation. Just how much has it done whatever it's done, rain, snow, sleet, hail, in the last 6 hours? In this case, it has snowed 1/4 inch, according to this station model. And finally, something that I think might have been put on at the beginning here, and is kind of important, the dew point. And what we see in our example here is that the dew point, always in degrees Fahrenheit, is put at approximately the 7 o'clock, 8 o'clock section of our clock, just as this was put at the 4 or 5 section of our clock. Dew point, and in this case, dew point and temperature are almost exactly the same. I would say the only thing odd about this station model is that the cloud cover is only 75%, and yet it's snowing. So maybe that's a little bit weird. But of course, when the dew point and the temperature are close together, we should expect precipitation. So quickly, going to the next slide, this is what station models on a map might look like. Let's take New York. It's a little hard to see, but we have, and by the way, you'll note immediately, let's look at one that's easy to see actually, that they don't have every variable here. They've got the temperature in Fahrenheit, the dew point, they've got the cloud cover, they've got the barometric pressure, but no trend, no precipitation, no present weather. So it's not a complete picture, but it's giving whoever is using this data enough information to get a sense of what's going on in New Mexico. This would be probably Albuquerque. And so we're in Albuquerque, New Mexico. No chance of rain with a temperature of 65 and a dew point of 38. The wind from the southwest, west-southwest, I would say, west-southwest at 2 long feathers. That's then 20 knots with a barometric pressure of 1,099.8 or 999.8. Has to be 999.8. And then for New York, we would have our conditions in New York where we can't really see, I can't really see the wind direction very well, but I can tell you that the temperature is 68, the dew point is 60, won't rain, and the barometric pressure is 132, which cannot be 913.2, must be 10 or 1,013.2. And it could be that the wind here, oh, here it is, it's coming from the southeast at 5. The southeast at 5. That, ladies and gentlemen, is the way in which we make a station model. And I'll be giving you some practice on this using your variables collected in the month of April. Your weather variables collected in the month of April. So thank you, thank you, thank you.